Hello. So today I would like to kind of show you how to solve a system of equations using the graphing calculator option. So we have a systems of equations here that has three equations and three unknowns. So the first step would be to find the augmented matrix. Okay, so the augmented matrix is essentially just really a set of brackets and writing out the coefficients. So we have that we can label respectively each of the variables like x, y, z, and then we'll just put b. And now we just want to say that we're going to write out the coefficients of the matrix. Now we can actually separate the matrix with a vertical line, and that's just going to be like where the equal sign will go. Now I need to write out my my coefficients of my matrix. So let's put that for the first augmented matrix, we're going to have that's going to be 1, 1, 1, and we have 10, followed by 1, -1, 5, and 24. Okay, well, we got one more row. So that's going to be 5, 1, 1, and then 18. Now, we can go ahead and try to figure out like the solution to this matrix by using the Gauss-Jordan method, but for the most part, we know that yes, that's going to require a set of row operations. So I'll just put this as a note, and we'll just say that we want to find the row reduced. And technically it's the echelon form. Okay, now just as a reminder, like what does that look like? Well, that looks like where we have a matrix with a set of ones and zeros. So like 1, 0, 0, 0, 1, 0, 0, 0, 1. And then we just put our answer as follows. Like if we have like, let's use, we'll probably have to use different letters for this one. So maybe we'll just call it M, N, and P. So this is telling me that my matrix is of the form, let me just erase this. So we'll just say that our matrix is of the form 1, 0, 0, 0, 1, 0, 0, 1, and that our solution in this case would have to be x equals to m, and y equals to n, and z equals to p. Now, it's a little strange that we have that kind of answer, but, you know, it's just really more or less like a process that you have to go through to get these solution sets. So why don't we enter in this matrix into our calculator so that we can see like how is that done. So we'll just need to do, let's move this over here. So let's go to second matrix. Let's go to edit. We're going to select that. Now this is a 3 by 4, I believe. 3 by 4. And the entries are going to be as follows: 1, 1, 1, 10, and then we have 1, -1. Wait, we're going to have to delete some of these. So that should be a 1, and then that's a -1. Okay, so yeah, just got to be careful in how we enter this in. Okay, so let's go to second quit. Now if you want to display the matrix, you can always call it back. Let's just move this over here. Okay, so that looks about right in terms of like what we needed for the augmented matrix. So what we'll do here next is we'll just say that we're going to go ahead and find the row reduced echelon form, and that's under RREF. And we're going to select the matrix that we just saved it as, and we're just going to close that and hit enter. So this is telling us that the solution to this set is 2, 3, and 5. So what that means is that we can go ahead and say that, well, we found our matrix, like when we row reduced it. So we figured out that the row reduced form of it is 1, 0, 0, 0, 1, 0, 0, 0, 1, followed by a 2, a 3, and then a 5. Meaning that the solution set would have to be x equals to 2, y equals to 3, z equals to 5. And that would be our solution to that system. Okay. Now, what you can do is figure out what the solution to this system right here, what it would be. So you'll have to input this into your calculator. Just do that again. Okay, so go ahead and figure out like what the solution of this would be.